Yes, welcome back, and then let's try to see our answers there. I'm sure most of us have got it like this. As we have said it, we could only round it off to our final answer there. As you can see, we round it off to 2 decimal places. Among us, I'm sure they've tried to simplify 23,000 divided by 1,570. Then they've got a long number, and then we've said it on our notes that don't round it off here after getting the decimal of this common fraction. All right, what is important, you have to round it off towards the final answer. Be careful, or else you're going to lose some marks there, okay? I'm sure you're clear. As I've said it to you, our next topic that we're going to look at is going to be the depreciation, okay? Let's try to look on the depreciation and see what we've got here. And then depreciation, what is the formula for depreciation that you're going to use for depreciation? Let's get one example here. Okay, we are right there. Depreciation, let's see what we have here. We've got an example on the depreciation. What is the formula? Now let's read the statement. Then I've got this example for us. I know you're familiar from grade 11 work. When we deal with the depreciation, remember we look at the key phrases. Then our key phrase there, as I keep on saying, depreciation. Then here we've got the depreciate. Can you see that word? It's a depreciate. And then the statement reads as follows. As we've said, you have to read the statement first. It says a photocopier valued at 24,000. Photocopier is a machine valued at 24,000 rand, depreciated at the rate of 18% per annum on the reducing balance method. After how many years will its value be 15,000? Okay. After how many years will its value be 15,000? So what are the key phrases or keywords, sorry? And then the first one, we indicated the depreciation or to depreciate. And then the other one is the reducing balance method. So which means from our formula that we've got from our formula sheet, we must remember which one is relevant to us. Let me take you back once more and take you to the formula sheet, and then you see what we've got there, and then we're going to choose the relevant one. Let me take you there, and then we make a proper choice on our, all right, okay, all right, here is our formula, the formulas that we've got, that we've listed here, the formula that we've got here. Yeah, we have to make sure that we keep. From this formula, we have to identify the formula that is relevant for reducing balance. Okay, because our keyword is depreciation. Under depreciation, we look at those ones that have minus. If you see minus, then which means if you can look at 24,000, it went down to 15,000. Okay, can you see? It was not going up, but it just went down. So since we've got this one and that one, but the another key phrase that we've got there, it says, what it does, it says we have to use the reducing method. So this is going to be a choice. As I've said, it is wise if you can write reduce balance method, the straight line method, and so on, investment, and so on, compound, and the simple, and so on. So that when you get here, you go to this one specifically. So this is the formula that we have to look at, okay, according to our notes, okay. Now let's go back to the problem and then get to the solution of that problem, okay. Here is our problem that we have to do it. Now, from this problem, let's try to put our let's try to get the information on this one, the data that we've got. We must have our A. I'm sure you're writing your A, and then you're going to compare with my A, and then we've got our P, and then we've got our I, and then also you must find N. Okay, now I'm going to write my data and then compare it to yours and then see whether you've got it right. But one thing for sure, I know some of us, they might make a mistake with depreciation. If you compare 24,000 and also 15,000, let's see. But for the rate, which is 18%, all of us, I'm sure we can get it right. But I just want to, we're going to laugh to some of us. But this is going to be a joke that is going to take us somewhere where we're going to correct ourselves with regard to depreciation, the key phrase that we've got there. So then I'm just going to write my A, and then I'm going to write my P, which is the initial amount. Then let's see whether we've got the same thing, and then I have identified the formula. All right. Then let's see. Let's compare our answers and see. All right. This is what I've got. Let's see. Let's compare our answers and see what we've got there. Can you see what is happening? Here we said it depreciate, which means it comes from here, it goes to 15,000. From 24,000, it becomes smaller to 15,000. That's indication of depreciation. Okay. That's the indication of depreciation. Okay. Now, from the depreciation, what is happening there? What do you say? What can you say there? This is what is crucial. Be careful about how do you interpret the depreciation. All right? So that you can substitute them correctly on a formula. The values that you've got here will indicate it to you. Your principal must be greater than your A. So I can even write it here. So your P must be greater than your A under depreciation. Okay. All right. Let's try to take into consideration that one. Okay. Right. Now we are looking for our N. Okay. Let's try to calculate our N there and see what we've got there. As you can see, our N, which means we are going to apply the logs. Applying the logs. So what is your A? If you substitute your A, it's 15,000, and then your P is 24,000 into 1 minus I. I prefer to write it as a decimal so that you can work it out with this one together. All right. So then that's the picture of what we have, or you can even write it as 18 divided by 100, because 0.18 is equals to 18 divided by 100. Okay. So this is the substitution. We just went to another step that is crucial in your work, that you must substitute them correctly. But you'll only be able to substitute them correctly if you have put your data, or written your data, used in the statement. These are the data used in a statement. You cannot put any other data from anywhere else apart from the given statement. Okay. So let's see what we have here. Then what is left for us? Now we are aware that from the previous exercise, under the compound interest, we are supposed to find our N. Also here we have to find N, so we can't waste any time. What is our N here? N is equals to log 15,000 divided by 24,000, all divided by log into 1 minus 0.18. So it's your N. So I just want to emphasize, I'm sure now we are clear, and then on when do you have to apply your logs, only if we look for N under the reduced balanced method, or also under the compound interest. Okay, just take note of that. Okay, right now here all what is left for us is just to get straight to our calculator and we punch it, and as we punch it and round it off to 2 decimal places, this is going to be 2, according to my calculator, 37. Okay, that's my answer for that one. Okay, and as you continue, then that's the picture of your N. Okay, so which means it's 2 years, and then you can convert that 37. Then this is your final answer for your N. Okay.